students, welcome to Shruti Academy. So let us start with the question number 1 and 2 of exercise 7.2 of chapter 7 integrals for class 12 CBSE NCERT. Okay, so we have to integrate the following functions. In the first question it is being given to us 2x upon 1 plus x square. So this exercise basically is depicting the method of substitution. It is of, we have to apply over here the method of substitution over here. Okay, so we will be substituting some by some variable, and we will be making a whole of the expression in that variable only. Okay, we will be solving these questions as follows. Okay, so here we have been given to us 2x upon 1 plus x square. Okay, so 1 plus x square we will be substituting to some variable. Let us assume it to be equal to t. Okay, so let 1 plus x square is equals to t. We have assumed to be this. Now we need to convert this whole expression in the terms of t. Okay, now we need to integrate this whole, integrate 2x upon 1 plus x square. So here we have to convert all these x in terms of t. Now in order to convert 2x in terms of t, because here we are having dx. Right now the whole of our expression, whole of our problem is in terms of x. So we will be converting in terms of t. Okay, so if we are going to differentiate 1 plus x square is equals to t, so we will be getting in terms of t, and we will be getting over here dt basically. Okay, so let us differentiating both sides. Okay, differentiating both sides. So we will be getting over here 0, or you can write over here d over dx. Here we need to differentiate with respect to x, 1 plus x square. Okay, and here also we are going to differentiate t with respect to x. Okay, now when we are going to differentiate this with respect to x, differentiation of any constant is always equal to 0. Okay, so it will be 0. Straight away we can write over here 0 plus x, where x to the power n, when it is differentiated we get nx to the power n minus 1. Okay, I am writing over here just to recall, x to the power n is equal to nx to the power n minus 1. So here we are having 2, so 2 to the power 2x and to the power 2 minus 1. Okay, and here already we are having dt over dx. Now here it is 2x. Now this dx we are going to take to that side, so we'll be getting over here dx is equals to dt. So we are going to substitute 2x dx equal to dt. In the place of 2x dx we are going to substitute dt. Okay, so our expression now becomes, let us see what it becomes, 2x upon 1 plus x square dx. Now it will become equal to integration 2x dx will be straight away dt, and 1 plus x square we have already assumed it to be t. Now our whole expression have been converted in the terms of t, and it is much simpler to integrate 1 upon t instead of 2x upon 1 plus x square. So this is the method of substitution. Okay, now 1 upon t, when we integrate 1 upon t we always get log t. So the integration of 1 upon t will be log t plus c. C is the integration constant and log t is the answer. So in this manner we need to substitute and we need to solve our problem. Now since our question was in the terms of x, so again whatever we have substituted we are going to put over here. So we have substituted 1 plus x is equals to t. So in the place of t I am going to put 1 plus x square. Okay. So ultimately our answer will be log 1 plus x square plus c. So this is my answer. So this is my answer. Okay. So now let us move on to question number 2. Here also we need to do substitution and we will be substituting in terms of another some variable. You can take any of the variable. It is not compulsory that you have to take t only. You can take any of the variable and you need to substitute it. Okay. So now the question is, second question is log x whole square upon x. Now it becomes somewhat typical how to integrate log x upon x, and that too log x is having a square in it. Okay. So what we will be doing, we will be substituting again. So we will be assuming let log x to be equal to some variable t. Okay. You can also take another variable u, v, w, whatever you want. Okay. So I have taken over here t. Now again the same process we will be doing, same steps we will be doing, differentiating both sides, differentiating both sides with respect to x. With respect to x. Okay. With respect to x. Okay. So over here d over dx log x is equal to d over dx t. Okay. So we can easily differentiate log x. We are knowing the formula for the log x. We have also seen in the differentiation chapter how to differentiate log x. So log x is always equal to 1 upon x. Okay. And from here it is always dt over dx. So this dx can go that side. So it will become 1 upon x dx is equal to dt. 1 upon x dx is equal to dt. Okay. So this is here we need to integrate. We will be substituting 1 upon x dx whole to be equal to dt. So we will be getting the integration in terms of t, and we will be integrating with respect to t. Okay. So here the expression was log x whole square upon x dx. So 1 upon x dx can be substituted as dt. This can be substituted as dt, and log x is t. So this will become t square. So this will become t square. Okay. So now here comes integration t square dt. Okay. So integrating t square with respect to t. So integrating t to the power n. So the formula for t to the power n is t to the power n plus 1 upon n plus 1 plus c. Okay, I am writing over here. So integration of t to the power n dt will be t to the power n plus 1 upon n plus 1. Okay. So this is the formula. So when I will be integrating t square, I will be getting over here t to the power 2 plus 1 upon 2 plus 1 plus c. So ultimately the answer will be t cube upon 3 plus c. But this is not my answer because my question was in terms of x. So my answer also should be in terms of x. So whatever I have assumed log x, I will be again resubstituting it back. Resubstituting back t to be log x, and I will be getting my answer. So my answer will be log x whole cube upon 3 plus c is my answer. Okay, so in this manner we need to proceed such type of questions, and in this exercise we need to basically emphasize on the method of substitution, and in this way only we have to do all the questions of this exercise. Okay, so thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.